Hi everyone. Um, Today we will be learning about graphing square root functions. So I hope you are ready with your pencil, ball pen, or notebook so you can take down notes of some important details to this lesson. So at the end of the lesson, you must be able to graph square root functions and translate graphs of square root functions. So a square root function is a function containing a square root with the independent variable in the radicand. So the parent square root function is y equals the square root of x. So we can graph the parent function y equals the square root of x by assigning the table of values. So when x is equal to 0, so therefore you have y square root of 0, and the square root of 0 is 0. That's why I have y equals 0 there. When x is 1, so y is equal to the square root of 1. So my y is 1. That's why I have 1 there. When x is 2, so y is equal to the square root of 2, and the square root of 2 is approximately 1.4. That's why I have 4 there. When x is equal to 4, so y is equal to the square root of 4, and the square root of 4 is 2. That's why I have 2 there. When x is 9, y is equal to the square root of 9, and the square root of 9 is 3. That's why I have there. So to plot that, this is 0, 0. This is 1, 1. This is 2, 1.4. We have there 4 and 2. And this is 9 and 3. We can also graph that using Desmos. So you can verify it using Desmos. So I have y equals the square root of, where's the square root here? The square root, where is the square root sign? Okay, this one, I'm sorry. The square root of x. So this will be the graph. Same thing with this one. Okay. In graphing square root function, sometimes we have to find its domain. Say for example, this problem. Find the domain of the square root function when the given square root function is y is equal to 2, the square root of 3x minus 9. We don't care whatever variable or expression outside the radical sign. We are only concerned what's inside the radical sign, because the value of the radical sign there inside the radical sign must be greater than or equal to 0. So hence 3x minus 9 should be greater than or equal to 0. Again, we don't care whatever the value or expression outside the radical sign. We are only concerned about what's inside the radical sign. So the 3x minus 9, its value must be greater than or equal to 9 to make it define. So solving for x, it's like solving equation. So 3x greater than or equal to 9. So this is 0 now. Dividing both sides by 3. So my x is greater than or equal to 9 divided by 3 is 3. In other words, the domain there is x greater than or equal to positive 3. So anything is possible. To make it define, the value of x must be greater than or equal to 3. So this is the answer. Now, let's have number 2. What is the domain of the function y equals the square root of negative 2x plus 5? I repeat, we are only concerned with what's inside the radicand sign. And the radicand sign is 2x plus 5. The value of 2x plus 5 must be greater than or equal to 0. Because when that is less than to 0, a negative number don't have the square root, at least for this lesson. Solving for x, so you have to subtract both sides by negative 5. So you have there greater than or equal 0 minus 5, it's negative 5. Dividing both sides by negative 2. Remember our lesson that when we multiply or when we divide a negative number, you have to get the reverse of the inequality sign. Since we divide a negative number, you have to get the reverse of greater than or equal, and that is less than or equal to positive 5 over 2. It's positive 5 over 5 because negative 5 over negative 2 is positive. So the domain here is x less than or equal to 5 over 2. Okay, so I want you to try the practice exercises in your Go formative. I'm going to give you like a couple of minutes before we continue with the video.